Hi everyone, thanks for your session. Today, my presenter Kevin and I will give a talk about the TF-M remote secure service with Zephyr. TF-M is trust firmware for M. It's an open source implementation of PSA. I'm a car now working in light and then running. This is the agenda today. I will introduce TF-M with Zephyr on single core and multiple core, and then go to TF-M remote service for details. As you know, TF-M on single M33 is a common usage to extend the security of the system, but TF-M can serve secure service more than that. Its scope will be a secure center of the rich-end devices, as security is not an optional at everywhere of IoT world. So a multiple core solution is necessary. And then my co-presenter Kevin will give an introduction for PSA certified of these scenarios. TF-M was start from a single V8M processor, and it separated into a SP and NSP that is officially supported usage. For the Zephyr with TF-M on single Cortex M33 is following the same. As the diagram shows, the NS call secure services by NS APIs to secure. Each secure service in TF-M will have its own APIs. We call it library mode of TF-M. With the TF-M support more and more secure services, the NS APIs grows fast. Based on that, TF-M evolved IPC mode to handle that. The advantage of IPC mode is huge. All services are sharing the same suite of PSA APIs. No matter how many services added in the TF-M, they all can share the same suite of APIs for NS side. The TF-M IPC mode supports asynchronous access to different services. This is more stable, more elegant, and also an extensible mechanism for multiple core. Based on TF-M IPC mode, the difference from multiple core support to in TF-M to single core is a communication and a function call between processors. For the following slides, the IPC stands for interprocessor communication. In multiple core system, TF-M is responsible for secure features, and it runs in secure state of Cortex M33 or running in a physically protected V6 or V7 as a primary core. The diagram shows the high level of TF-M remote call for service by leveraging the OpenAMP and ERPC. It has decoupled each part significantly, as it shows from the diagram. The NS daemon, black side, the NS daemon holds the ERPC server and OpenAMP master. The daemon handles the request from the client and then passes to SPM on behalf of non-secure clients. No changes to SPM or TF-M core itself. This can keep the TF-M original and integrity. OpenAMP and ERPC are standalone libraries too, which are online export APIs to TF-M. By this way, the non-secure application could get the long-term support of TF-M. Since TF-M evolves fast, it may support more features, more secure services from version to version, and also the optimization and the refactor may happen in TF-M too. Besides the secure CPU can be M33 or any M profile call. Each scenario will rely on the secure features of TF-M. TF-M acts as a secure island to protect all sensitive information in the system. As non-secure calls can be various, but the interfaces are uniformed by PSA APIs. It is going to simplify the remote procedure call. The non-secure has OpenAMP and ERPC in the same way to cooperate with the secure side. Let's look at more details about the remote service. There are many toolpaths to implement the RPC for requests. RPC means remote procedure call. The first part is communication between CPUs. We take RP message in OpenAMP to transferring data. The second part is to handle the remote procedure call. ERPC project from NXP is a choice in this solution. It has a server side and client side separately. By this way, all functions from remote CPU to TF-M, like calling a function locally and get data return. The difference will be transfer latency from the channel. How to distinguish different APIs which have different parameters is a question here. To handle this, ERPC supports a shim layer which can serialize and deserialize the function call. And also, ERPC supports a generator tool to generate the shim layer code from for both sides by using RDL. RDL is interface definition language. These three on the slide are part of PSA APIs for reference. The first one, for example, it declares an interface that host function's name is PSA version, and it has a input parameter when invoke the function. After the function finished, it has a return value, which is also an unsigned int. ERPC generator, which can generate the code from this RDL function. From the RDL, the generated code for ERPC is in master side is serialize the function call, and in client side is to deserialize the function call. Okay, this is the introduction for TF-M to support the remote secure service. The next slide will be an update of where we are for this support. Firstly, the TF-M with Zephyr on single M33. This is already supported in Zephyr's master branch. Current ARM platform has mask A, mask B1, and N521 on MPS2 board. These are already supported in Zephyr master. For Zephyr on dual core is based on OpenAMP to communicate each other. This also has been done. Now I have an example to run Zephyr on multiple CPUs. All over the CPUs are running Zephyr, and they communicate with each other by OpenAMP. But on ARM platform, we're using MHU to notify each other's. MHU is a message handling unit, which can trigger interrupt to other cores. For the TF-M and Zephyr on dual core is in progress. TF-M on secure CPU, Zephyr on non-secure CPU, and both of them support MHU, OpenAMP, and ERPC, this kind of stuff for remote service. But this work now currently not upstreaming. I put them on GitHub, but we can demo it now. This tool is going to illustrate how each part works. You can see I request from the non-secure side to secure, and then SPM starts to work. After the SPM finished all the functions, then will return to non-secure side. Two CPUs will communicate each other by OpenAMP and notify to each other by MHU. If you are interested in the demo, welcome to the demo Friday. And that's my share today. Thanks. For the next, I will pass to Kevin for more about the PSA certified.
Thanks, Carl. Okay. Obviously, I assume if most of you guys are here, you're interested in security in general, especially protecting the IP and the firmware assets on your device. So I assume most of you are familiar with Trusted Firmware M in general. A key part of that is obviously having a sort of a strict isolation between the secure and the non-secure elements on your devices, so that whether you're storing private information or keys or whatever, that you have a hardware mechanism to control access between resources and memory and critical resources. And something my colleague mentioned several times in his discussion of how to use either single or dual core with TF-M is the PSA APIs, which come from the Trusted Firmware M repository, which basically defines in software the mechanism by which the non-secure and the secure cores can communicate with each other, and whether that's for cryptographic primitives or securing data or entropy or whatever else. So just in this general theme, though, of security, I think we wanted to highlight a term that you may or may not have come across looking into TF-M, which is PSA Certified, specifically PSA Certified Level 1, Level 2, Level 3. So what is PSA Certified? Obviously, it's you're probably familiar with platform security architecture, but what a product that you have designed, or an RTOS, or a component that is PSA certified, is basically, it's like a stamp of approval, in a sense that your product meets a certain minimum set of requirements, a minimum set of security due diligence that has gone into things, depending on the type of product, whether you're an RTOS vendor or a chip vendor or an OEM product vendor. And basically, what you will do is you will run your product through this process that will end up with a specific unique ID associated with your product, RS or OTM. And obviously ARM is a significant player in this, but it's not uniquely ARM. There's a sort of a relationship with some of the largest test labs out there that are independently verifying this beyond just sort of ARM's participation, who they've helped define this, but the tests themselves are actually executed by independent partners. So what is PSA certified specifically? Basically, there are three levels today of PSA certification. Level 1, which is sort of the minimum level, which defines a set of basically best practices that are or maybe requirements that need to be met by your product in order to it's basically an assurance that you're meeting some common criteria. For example, that there's a secure bootloader, that by default you're using strong modern cryptographic processes and primitives, that sensitive data is being securely stored. And in order to get the certification as a PSA certified level 1 product, essentially there's a questionnaire that needs to be filled out. And this questionnaire will be sent to one of currently 4 independent test labs, who will validate that the processes that you've described for your product actually meet those criteria. And there are basically 3 distinct sections to the questionnaire, depending on if you're an RTOS vendor, a chip vendor, or an OEM provider. Beyond that initial approach, there are a significantly higher level of scrutiny that will be applied to your product in the case of PSA Certified Level 2, which is where you will actually, if you're a chip or a product manufacturer, your physical device will actually be significantly sort of tested and poked and probed and abused by an independent lab to see if sort of what are the most common weaknesses that they can get out of that device. And that's about a 25-day process in general with the independent labs. PSA Certified Level 3 is, in general, still in development. Feel free to correct me, someone from Arm, if I believe Level 3 is still in development. But that will basically be even sort of more scrutiny paid to the actual device analysis and teardowns and things like that. So in the case of our work with RTOS, with Zephyr though, specifically, we've been focusing on getting Level 1 Zephyr certified as a PSA Certified Level 1 product as an RTOS. And essentially what that means is we're taking this questionnaire, which if you're interested, it's freely available here at this link. Filling that in as an RTOS vendor. If you're a chip vendor or whatever, the process is the same. It's just the technical questions are slightly different. And the end result will be, in this case, you can see the certificate here for Arm Mbed OS. We will get a unique identification. And essentially the goal isn't just a magic number that keeps somebody in marketing happy and it's a nice stamp. It is actually a genuinely meaningful effort, in a sense, to ensure that there are the most common sort of vulnerabilities are being addressed. And so it's having gone through the process of sort of filling out the questionnaire, that the questions are, they do force you to think about some common scenarios that will, for the amount of effort involved, will result in a more secure product or more secure RTOS or chip design, etc. So we've been going through this process with Zephyr RTOS with the Zephyr project at the moment. There's currently, if you're interested, there's a PR number up here, and there's also another PR from my colleague, 16450, where we've been making the efforts to make it as easy as possible, basically to integrate the TF-M repository, which will handle, at the moment, the secure side, and to integrate that easily into Zephyr and to integrate that into the Zephyr build system. So if you're interested in that work, this is one of the PRs you can look at. Part of that process, obviously, is integrating. Zephyr does use MCU boot out of the box, but there's a sort of a more specialized version of MCU boot in the TF-M repository called BL2, which we pull in as a replacement as part of these PRs. And the verification of Zephyr as to have PSA Certified Level 1 is currently in process. I'm hoping to send, probably by the end of the week, the questionnaire out, and in a week or two, hopefully we can get that back. The questionnaire will most likely be available for reference if later, as maybe a product vendor, you want to run through the process of getting your specific product or device, OEM device, PSA certified as well. At least you'll have a reference for some of the work that was done there. Yeah, and so I guess that's the long and the short of it. I'm not sure if you have any questions either about the dual core approach or what are some of the advantages and benefits of PSA certified, the different levels, etc. I guess there's a bit of a disconnect between the dual core and then the bigger picture security sort of review that the PSA implies. But yeah, if you have any questions for either of the two parts. Maureen?
Is the PSA Level 1 certification questionnaire tied to a particular Zephyr release, such as the LTS or 2.0 or
it will be tagged to a specific commit at the moment. I think, obviously, the goal would be maybe 2.1 or something like that, or 2.0. Probably 2.1 makes more sense. But yeah, it will be the goal, at least in my head, and I'm only speaking for me here, would be to tie this to a specific release, just so that if somebody does care about sort of this specific release and the specific moment that the certification happened, that it will be a major milestone. So yeah, I mean, 2.1 was kind of what I was thinking to base the work off in my own head, and that's subject to discussion with the TSC, I think.
Okay. Thanks.
Yep. Anybody else?
There are three functions: attestation, cryptography, and secure storage.
Yes.
Would all three be included in that?
Yeah, at the moment, basically the PR that I mentioned, the goal of that is to make a sample Zephyr application that will essentially demonstrate how to use, for example, the crypto API and the secure storage. For example, I will have an example of storing information on the secure side and accessing that later. So yeah, the goal is to have a sample application that demonstrates those three key services on the Zephyr side. So we're using Zephyr on the non-secure side at the moment, and then TF-M will be on the secure side. But obviously then, whether that's a single core or dual core as a solution, as my colleague will demonstrate Friday, talking to those three services, and we'll have, as part of the process of getting Zephyr PSA certified, we'll have a sample application that shows how to use those three different services to communicate securely or store config data, and how to, as part of the requirements, how to securely erase that config data if you need to put your device in a factory default state or something like that. So yeah, those three services will be covered as part of the sample application that we're going to use for the level 1. So, sorry, does that answer your question?
Okay. You said that you will tie it to a certain release. What happens after that release? Is there a plan to maintain some kind of record of either the conformance or deviation? And are you planning to add tests to CI or something where it will be kind of clear that when you've actually broken it?
Yes, yeah. I think Zephyr has a fairly decent, I think, already sort of test infrastructure built in around it, and yeah, of course, the goal is that this is actually the main difficulty in getting this work merged into Zephyr was the CI system, because we want to obviously continue to execute and to build and to test the PSA sample application every time there's a commit in CI, and we've been doing some work, for example, to get this to run in QEMU, which as of 4.0 you can actually, it has decent support for TF-M, so we should know if at some point there's a commit or a change that happens, and the TF-M separation between processing environments breaks, so that should come up fairly quickly. What we do with that in terms of if there's a major breaking change, how that affects the certification, I'm not sure, but there's definitely a build and a test system in place to detect as soon as something breaks.
I think that makes sense at this point.
Based on QEMU 4.0 at the moment. So yeah.
So my question is, the ARM has released its version to support solution level 2. So
Yes.
and do you have plans to support that? And do you have plan to pass the level 2 test?
Level 2 testing, I guess it doesn't apply to the same extent.
Certification, level 2 certification, yeah.
So it doesn't apply to our specific focus at the moment is really to get Zephyr certified as an RTOS, which is really more relevant to level 1. I think level 2 would be maybe a different set of users. So I mean, we're happy to provide some feedback on that, but sorry, you've got some.
Either Chevy or I can answer that question for you.
Okay. Somebody wants to give him a mic. Yeah.
Go for it. Oh. So level 2 is actually aimed more at the silicon itself. So that's where that additional penetration, 25 days of penetration testing come in. It really is not implying any additional functional requirements from the RTOS. So that's why it doesn't really require a level 2 for RTOS. Although when they fill out the forms, they will say, I'm using this RTOS, and it either has or has not been PSA certified.
Yeah.
Certifiability aspect remain in level 2 for the RTOS, or not, once you've done level 1,
that's sufficient.
So yeah, for the moment, in the case of Zephyr and the work we've been doing, we've been just focused on level 1, and level 2 becomes more of a relationship with the test lab and if you're a manufacturer.
So now the TF-M integration is specific to the Musca platform. So how easy is it for other platforms, V8M platforms that's supported in Zephyr, to get the TF-M up and running?
I think we've been using the MPS2 and Musca. On the Zephyr side, I think it's fairly easy. The difficulty is more because at present on the secure side, we're pulling in the trusted Firmware M repository, and that's more the limitation today. Is if you want to get this as things are today out of the box working, then you will need to add support for your board also on the TF-M side, which is perhaps a little bit more involved than it is to necessarily add a new board on the Zephyr side, which is relatively, you can do that in a day or so if you know what you're doing. So that's at present, yes, we're focusing mostly on the MPS2 and the Musca boards because those are well supported in TF-M. So that would be the major hurdle. And I've done some initial work to try to get this working with the LPC55S69, for example, which is a dual core M33. And yeah, the only real work is just getting that to play well with the TF-M build system. And because there's a bit of a learning curve there, maybe more than there is with something that there's a lot more examples on Zephyr to follow than there currently is on TF-M. So, but that would be the only real investment required is to get your board working with the TF-M repository. So. Anything else? I guess I've got about 30 seconds if somebody else. Okay. Well, thanks for your time. And if you do have any questions, feel free to ask Carl or myself, and we'll be giving a demo Friday, so I'm more than happy to dig into this in more detail if somebody's interested. So, thanks for your time.